Good morning. Today we will learn the topic motion of a body in a straight line. What do you mean by a body moving in a straight line? For example, when you take a car, let us say the car is moving from one point to another point. Fine. Now it's going from one point to the another point. The motion of this car moving from one point, let us say A, to the point B, the study of this we are going to do in this chapter. Any body for that matter. Before going into the details of motion in a straight line, first let us define certain basic terms. What do you mean by motion? And what do you mean by rest? When I take a body, let us say this duster, if the duster does not change its position with respect to the surrounding, I am watching this duster, others are watching the duster, and it is not changing its position. When it does not change its position, the body is said to be at rest. If the body after a given time changes its position, it moves from one point to the other point, then we say the body is in motion. The body is in rest, it does not change its position. The body is in motion when it changes its position with respect to the surrounding. Now, what do you mean by distance and displacement? You'll find that distance is the actual path traveled by the body. For example, I start from the point A, I move to the point B. Let us say I travel 3 kilometers. So the distance traveled is 3 kilometers. Now, I decide to go somewhere to another point C, let us suppose, which is 4 kilometers from the point B. Then the distance traveled is 3 kilometer plus 4 kilometer, 3 plus 4, which is equal to 7 kilometer. That is the distance traveled, that is the actual path traveled by the body. But what is displacement? Displacement is the shortest distance between these two bodies AC. The body is here, it moved to point B, then it moved to point C. So this is the actual path traveled by the body. But displacement is from here, the initial position to final position, this the shortest distance, which we call it as displacement. Now, what is the value of the displacement? And this is the right angled triangle. We can use Pythagoras theorem. According to that, AC square is equal to AB square plus BC square, and which is 3 square plus 4 square, which is 9 plus 16, which is 25. AC square is 25 and AC is equal to under root 25, which is 5, and here it is kilometer. So this distance displacement is 5 kilometer. See, the distance traveled by the body is 7 kilometer, and the displacement, actually what is the point it started and where it ended, is 5 kilometer. This is a very simple way of learning distance and displacement. With that, it comes to the point of speed and velocity. What do you mean by speed? Speed, the car is moving with a particular speed. Speed is distance traveled divided by time taken. Distance traveled divided by time taken. For example, this is the road, let us say, and this is the ball. It's moving from the point A, it comes to some other point B, and the speed is how much distance the body traveled and how much time it took to travel that distance. That is called speed of the body. In SI system, distance is measured in meter and time is measured in second. So, unit is meter per second. This is the unit of speed. Meter per second. You can write like this also. Now, what is velocity? Velocity is also equal to speed, but velocity has a direction. Let me explain it to you. What do you mean by velocity? Velocity usually we define as displacement upon time or speed in a given direction. For example, always we need direction in order to represent motion of the body many times. For example, if I am having a point here in the road and the road goes in all the four directions, fine, and we know this is the north direction, south direction, east and west direction, fine. Now, with respect to this point here, let us say, if a body is coming in this direction, it is moving towards east direction. Let us say the car is moving here with 50 kilometer per hour. When a car is traveling with the speed of 50 kilometer per hour, this is the speed of the car. But in which direction it is going? It is going in the east direction. So, we say that the velocity is 50 kilometer per hour in the east direction. Let us say the same car is moving in this direction. Fine, the speed remains the same, but direction is now north direction. The speed, magnitude might be same, but you will find the direction is changing, so the velocity is also different. When you talk about velocity, we have to talk about the direction. Speed is just a distance upon time, and velocity is speed in a given direction. Many times we need to represent the direction of physical quantities, right? And those physical quantities are called vector quantities. We have two types of quantities. One is scalar quantity and another is vector quantity. In the case of scalar quantity, like speed, let us say 50 kilometer per hour or 50 kilometer per hour. The 50 is the number which we call it as magnitude. Fine. And kilometer per hour is the unit of the physical quantity, which is speed. Now, if I talk about a vector quantity, you will find that it also has a magnitude, a unit will be there, and in addition to that, a direction has to be specified. A direction has to be specified, north, east, west, south, whatever may be the direction which we wanted to give, we have to specify the direction. Now, we learnt about rest, motion. With respect to the surrounding, the motion, the body changes its position. Distance, displacement, actual path covered, shortest distance. Speed, distance upon time, displacement upon time, where it requires a direction. And also, we learnt about now vector and a scalar quantity. Scalar quantity has only magnitude and a vector quantity has both magnitude and direction. Now, we move from here to one of the most important points we are going to now study about. Okay. Let us say there is a straight line road. A straight path is there. Fine. And there is a car. The car is going to start from here. Fine. Position A. The car is going to move. Fine. And it is coming to this point here. This is the point where it is going to reach. This is the point B. The distance traveled by the car is, we use the term S. Why S instead of D, distance? S stands for spatium, space Spatium, the word spatium, from that the word is being taken. In olden days, it is called distance, so S we represent. Now, initially the body is at rest, let us say, so we call it as initial velocity u. The body is in motion and it is taking a time t to reach from this point to this point, let us say. Now, when it comes to this point, let us say its speed is changing, and that is called final velocity. So, initial velocity is the starting velocity. It can be 0, it need not be 0. For example, in the road, you are seeing a car moving. It may be going with a particular speed. At the velocity speed, let us say, and that will be u. And when it reaches some other point, it can be v, that is called final velocity. So, what is the connection between initial velocity, final velocity and time? This is called acceleration. What is acceleration? In your scooter, in your bike, in your car, you accelerate it. You increase the speed. You increase the speed. The increase in the speed, the change in speed with respect to time. Change in speed with respect to time, that is called acceleration. Or more precisely, as an equation, we can say A is equal to final velocity minus initial velocity upon time. This is called acceleration. Now, what is the unit of this? Meter per second is that of velocity, and divided by time is second. So, meter per second square, which is equal to meter per second square, this is what is the unit of acceleration. The body is increasing its speed, that is acceleration. But I find a small pit or something like that, so I slow down the speed of the body, and that is called retardation. You increase the speed, it is acceleration. You decrease the speed, that is retardation. Retardation also can be called as negative acceleration, because the answer will come in negative. With this, we come to the last point which we are discussing. What is uniform motion and what is non-uniform motion? Fine. Let us take the same car case. Fine. Now, let us mark it with the small parts. Let us say it is starting from this point, 0. Let us say 10 kilometer, it travels a distance of 20 kilometer, travels a distance of 30 kilometer, it reaches the distance of 50 kilometer, 40 kilometer. Fine. Now, it is starting from 0, 10, 20, 30 and 40 kilometer. If every distance 10 kilometer, if it takes the same time to travel, fine. First 10 kilometer, it takes half an hour. Next 10 kilometer, another half an hour. Next 10 kilometer, half an hour. And next 10 kilometer, half an hour. And such a motion where the distance traveled and time are equal. When a body travels equal distances in equal interval of time, that is called uniform motion. But it is usually not possible many times. You will have non-uniform motion. It takes equal distances which is fixed. First it may travel in half an hour. Next it can slow down or it can increase the speed. It can go in quarter hour. Next one it may take 3/4 an hour, right? Slow down due to so many reasons, traffic. And last again it can travel in half an hour, let us say. Again, it is traveling equal distances, but unequal interval of time, and that is called non-uniform motion. So, uniform motion and non-uniform motion. So, we need to use the term called average velocity. Average velocity is the total distance traveled divided by total time taken, which means we have to be clear about what is the distance traveled in each segment with respect to how much time it took in each particular segment, and that is called average velocity or average speed. And in the next class, we will continue with the three equations of motion using these points. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. These are the three equations of motion which we will do it in the next class, and we will see in the next video and derive it. Thank you.